Well, welcome to all of you, to all the participants to this BECoop webinar. I think by now we should be at the 4th or 5th webinar of this series that goes until May. I think Vanessa will anyway give a better introduction to the project just after the video, but we thought it could be nice to start by showing it to you. So let me share my screen.
Heating and cooling represents 51% of the EU final energy consumption. Over 3/4 of these needs are supplied by fossil fuels, unsustainable and harmful for the environment. Bioenergy is an available, local, renewable alternative, allowing local economies to thrive. It consists of using organic feedstock from agriculture, agro-industry, forestry and municipal waste to generate energy in various forms. 75% of bioenergy is used for heating and cooling, yet factors hinder its use. Introducing BECoop, a project funded by the European Union, aiming to democratize the use of bioenergy for heating and unlocking the potential of community bioenergy. BECoop is inspired by the ResCoop model, allowing individuals and communities to reclaim and democratize a decarbonized and renewable energy production, a cooperation between users, logistic chain actors, and local authorities. This circular economy approach empowers individuals and territories that embrace it, increasing energy independence, security, and resilience through local resources. It allows heating cost savings at a lower environmental impact, increasing social benefits in terms of well-being and reduced energy poverty. BECoop brings in knowledge and activities to improve the conditions to create a strong international bioenergy community. It provides tools to support existing and future community projects, making their development easier and further cutting down time and cost efforts. BECoop tests the implementation of community bioenergy heating schemes in 4 complementary pilot cases with different characteristics in Spain, in Greece, in Poland, in Italy. BECoop, unlocking the community bioenergy potential.
Working?
Yes. So hello to everybody. I'm Vanessa Gallo from FIPER, that regroups biomass district heating in Italy. And today we organize in collaboration with the Politecnico of Milan a specific webinar concerning the district heating, and specifically the biomass, the woody biomass district heating. I show you a little bit some data concerning the project. You saw in the video, we are different countries involved. And different as well actors. We have research actors and stakeholder. We are the pilot of Italy, and we represent the reality of biomass district heating and the biomass chain. Some data, a little presentation of FIPER. FIPER was chosen into the project because we have experience in biomass district heating. We regroups 96 operator and 28 company and forest consortium. We said always that our goal is to develop a forest management, a forest sustainable management, and the district heating are tools to develop local economy in mountain area. We were involved into this project, and we consider the energy community not in a legislative way, in Italian legislative way, but in a way omnicomprehensive. I mean, in Italy, the energy community are regulated only for the electricity. FIPER and the other partner into this project, we consider the concept of energy community in large context. We consider to involve different stakeholders into the development of a new plant of biomass district heating. There are here some number of FIPER, but if you want, we see later. I would like show a little bit our reality as Italian pilot. We identify 3 municipalities in Valtellina Valley. They are called Tovo Sant'Agata, Lovero, Mazzo Valtellina, are situated in Lombardia region in north of Italy. We had chosen this municipality because they were the different focal point for us important to develop and to start to sensibilize the people to develop and to make a startup of biomass district heating. There are the necessity to improve the management of local forests. There are a lot of forests, but the cut of wood are really small. The creation of local wood biomass community, and of course, in this moment, reduce the dependency of fossil fuel. And our goal is to reach the autonomy from the fossil fuel. We are the initiator because, as I said before, we are specialized in biomass district heating, and we support this true municipality to start a new one plant. Some data, we said always that if you want to develop a biomass district heating, and after the Professor Caputo go to explain better in technical term, the first thing you have to do is an analysis about the local biomass, the availability of local biomass. In this year, there are a lot of potential biomass to use, from public forest, private forest, and also from pruning, so for agricultural residues. So we said always that if somebody, one municipality or one enterprise wanted to start with a biomass district heating, the first thing I have to check is the availability of biomass in local and in short chain. We estimated the potential of biomass residue forest available into the area, and we realized that there are enough to develop the biomass district heating. So why we decided to involve these 3 municipalities? Because there are different company, forest and expertise in the territory. The administrator and of course the measure are really motivated because they wanted to improve a new biomass district heating to manage and to prevent the environmental risk in the mountain area. And we want as well involve the final client, because they have different private forests. So we would like involve this final client as a final consumer, but as well as a producer of biofuel. Just a short.
Just a summary.
Hello. Just a short, a really little picture about the idea of the project. We would like start up this district heating in the central of the district heating. It will be located in Tovo Sant'Agata, and then the network will connect the people in Tovo and Mazzo and Lovero. So that one is really useful because it's a plant that go to connected 3 different municipalities, and as you know, in mountain area is quite difficult to looking for a consultation with a different stakeholder. What we did in a collaboration with Politecnico, it was a participative process. We realized a roadmap since November 2020 until the development of the biomass district heating. And for sensibilize the citizens, we realized a survey that was distributed in each building and each family. It was a really important action to sensibilize, to involve more the people, the client, the final user into the project. Now I give the floor to the Professor Paola Caputo that got to explain better the technical characteristic of biomass district heating. As FIPER, we are available to receive any question or clarification by email or maybe after with the question time. Thank you. Please.
So good afternoon, everybody. We are dealing with biomass. Biomass is a renewable energy sources that includes a wide sample of materials, such as byproducts from agriculture, pruning, forest maintenance, and also dedicated cultivation. This source can be converted in different forms of energy and biofuels, depending on their characteristics. So going to the next slide, we can have a look of the most adopted type of biomass in district heating systems. This form of biomass is represented by wood chips from forest maintenance and pruning that is suitably chopped and then can be adopted in combustion systems or other thermal systems. So we can go ahead with the next slide. And what about biomass district heating in order to exploit these renewable sources, contributing also to lower CO2? One raising question can be if biomass is a renewable and carbon neutral source. The carbon neutrality of biomass is a very discussed topic, and without going into detail, since these issues have been discussed and addressed for years, biomass combustion, we can say just that biomass combustion returns the carbon stored during the tree growth to the atmosphere. So we can consider that the carbon cycle is neutral. Okay, but we can also consider the other CO2 emission that we have along the overall chain, including also the transportation, the transformation, and so on. And here in red, you can see also the results that are valid for the Italian context. So we can consider biomass at least for the 80% as renewable sources. And okay, this data can be considered as conservative, so we can be also more optimistic. And we can go ahead with the next slide, that is why adopt wood biomass for district heating. Okay, for using biomass in district heating, we have to verify a set of favorable boundary conditions, such as, for example, as Vanessa told before, the availability of these sources at territorial level, but also the availability of an heating demand in the same territory, and also the availability of machinery for the treatment of biomass. In many cases, this source is more present than we can expect. For example, if we consider Italy, differently that we might think, the forest heritage, because we can say forest heritage, there is a big heritage in terms of forest and woodlands. This heritage represents about 1/3 of the Italian territory. And this land is constantly increasing. So it is being protected and managed. And the protection of woodlands represents a cost for the territory and for the country. But we can manage this territory properly in order to have benefits in addition to cost. So in order to have these sources for thermal purposes, for example, for district heating. We can go ahead with the slide. Okay, so in addition to these issues, we have also to cope with the energy goals that we have at European level. And also we have to cope with other challenging global issues such as climate change and fossil fuel disposability. So we have to take into account that the biomass can help us also in this direction. And going ahead again, we have also a problem related to the approach to biomass, because this is a renewable sources, but renewable and available does not mean wastable. So we have to adopt biomass with the efficient, effective technologies. Biomass is still adopted at world level in obsolete appliances, such as fireplaces, stoves, and so on. This equipment must be abandoned, and district heating, in this sense, can represent an effective technology to exploit in an efficient way this potential. So we can go ahead again and have a look of the main drivers and challenges, again taking as example the Italian condition. So in summary, even if the country with the country that mostly adopt biomass district heating are, for example, Finland, Sweden, Denmark, Estonia, Austria, and so on. Also, Italy and similar other countries can be an important role in this direction. In fact, according to this slide, for example, we can have also a potential for realizing the double of the existing district heating plants in Italy. Let's have a look of the main features that we can find in this slide. For example, the withdrawal in Italy is around the 20–30%. I mean, in our forest, and the average in Europe is about the 60–70%. So we can exploit better this source. Biomass is programmable, and we can adopt this source for thermal use. So biomass district heating is the most effective technology in this to this end. And on the other side, we can consider that unfortunately only about the 1% of the heating needs in Italy are covered. Sorry. Okay. Are covered by these sources, because we have, on one hand, also competitive technologies for thermal generation. For example, gas boilers or oil boilers, or we have also the heat pumps. So these technologies are competitive. And if we consider the same source, that is biomass, we have competitive technologies to adopt this same source. For example, we can adopt biomass for energy generation, or we can adopt biomass in domestic appliances in our homes, not by district heating. Sorry, could you please switch off your microphone, because we can hear you and it is not so. Okay, thank you very much. So we can go ahead again. I don't know if this. I refer to my slide that is process for the realization of a biomass district heating system.
All good, we are there as well.
Okay, thank you very much, Marine. When we deal with this kind of system that is very complex, we have to consider several rings of the same chain. So we have to consider from the beginning to the final stages, and to try to take together all these stages. So we have to consider the estimation of the source availability and also the agreements that we need for organizing, for managing the biomass supply for our plant. Then we have to identify and involve the main stakeholders. Then we have to provide the most proper estimation of the thermal demand and evaluate the role of the final users, if these consumers can have the willingness to be connected to our system. Then we need to perform a complete feasibility study for determining the size, the types of components, technologies, the best operation modes, and so on. And then we have to consider the investment issues. So how to organize, how to cover the investment needed for the realization of the thermal station, and in particular of the network, that is a very expensive infrastructure for the territory. So we have to consider altogether these aspects, exactly as we are doing with the BECoop project for the pilot in Valtellina, and put together all these aspects. Okay, I think that we can go ahead again. So let's now go into detail about district heating, and let's consider the concept and the components. So in general, district heating means to supply heat or hot water from one source to a district or to a group of buildings. So district heating allows supplying heat from the central station to the final user via a network of underground and insulated pipes carrying hot water. Heat network can cover a large area, for example, a city, or also a very small cluster of buildings. The pipes are insulated, of course, are in the underground, and there are pipes to supply hot water and to return the water after the utilization, after the heat exchange with the consumers. And then we can have pipe for the transportation of the carrier and for the distribution with the smaller diameters to the final users. We can go ahead again with the presentation. Here we can see an example of pipes, excavation for setting the pipes in the underground, and also a scheme of the general structure of a network. The possible types of network can be branch, tree, or ring, but we can have also a meshed network. All these topology can have benefits and costs. The most adopted technology, the most adopted topology is the branch one. And in this case, we have that our carrier flows only in one direction, from the central station to the final user. Okay, let's go ahead. And now I can present the evolution of district heating. So let me give some general references of the history of district heating. Because indeed, this is a rather dated technology, is not a new technology, I mean district heating, but this technology is constantly evolving from the first generation to the last generation, according also to the evolution of the built environment and according to the innovation that we had and that we have about all these components. For example, we can consider the first generation in which the carrier was steam. Then we have the second generation, the third generation. For example, the most adopted operation for biomass is the third generation. So the supply temperature in our cases is around 90 degrees, and the return temperature in the network is around 60 degrees for biomass district heating. These are the typical ranges of temperature. But okay, this technology is in evolution, so we have to consider also that in the future we have to deal with this new components, new approach. For example, we have to think about the integration of thermal storage and integration of other renewables in the same network that is mainly fueled by biomass. So we had also to find out the solution for boosting the transition from the third generation to the next generation of district heating, even if the source is a biomass. So as I told before, we had to deal with thermal storage, try to understand the concept of heating and cooling with the same network, and try to integrate also the other renewables that we can consider at the territorial level. For example, also solar energy and so on. So now we can go ahead with the next slide, that is biomass district heating details. We can have a look of the main sections that we can have in a district heating system, in a biomass district heating system. As you can see from the slide directly, we have a biomass storage and supply, the first part, the first section. Then we have a combustion chamber and a boiler. So we have the combustion of biomass with the air in excess, and then we have the production of hot flue gas. We have the exchange with the water. So after that, we have the ash separation and the flue gas treatment section, and then at the end of the plant, we have the extraction of the flue gas. So we can have also the section in order to have an idea also of the spaces, the volumes of the main sections of this plant. So let's go ahead with the other slide. Here we have some pictures in order to better understand the main stages. So from the biomass supply and combustion to the hot water given by pumps to the network, and then to the final user. The last picture is a picture related to the heat exchange subsection that we have at building level. So also for my students that are here in this room, maybe from your point of view, this is the most important part of the plant because it is at building level, so at the user level. So we have to take into account that we will need also a technical room in order to have all these equipments, but we don't need a large volume. It is very compact, the substation. Okay, so we can go ahead again, I think. And here we have, again, some details about the central thermal station. So we have in the plant where we produce heat. So we have the section of combustion, then the heat transfer, and then the pollutant abatement. The combustion is the most adopted and reliable technology to convert biomass in energy, and usually it is based on moving grate boiler or in some cases fluidized bed boiler. So we can see better in the next slide some details. For example, here we have some details also of the flue gas abatement line. Sorry. Okay, details about the flue gas abatement line. So we can have some filters for the abatement of particular matter. For example, we can have electrofilter or bag filter or cyclones also. And on the right of the slide, we can consider also the systems for the denitrification of the flue gas. So, for example, we can have a selective not catalytic reduction or a selective catalytic reduction if we would like to reduce drastically the content of nitrogen oxides in the flue gas. Okay, and all these equipments allows to have less pollutants by district heating, lower than we can have, for example, adopting domestic appliances, as we can see also later. And now we can consider also some details for the cogeneration. On the left, you can see the most adopted equipment for the combustion, so the moving rate or the fluidized bed boiler. On the right, you can see the most adopted equipment for cogeneration, so for combined heat and power in such plant. So we can consider, for example, the technology of organic Rankine cycle with the size in the range from 300 kilowatt of electric power to some megawatt of electric power. And we can consider also twin screw expanders. That is another kind of technology that we can adopt also with the lower size. We can have also another completely different approach, and we can consider, for example, the Stirling cycle, or we can take into account, for example, the pyrolysis and gasification of biomass, and then the adoption of the syngas in a gas turbine. Okay, so we can go ahead and in the slide with the title, The Opportunity of the Cogeneration, we can see just the typical scheme that we have in a cogenerative biomass district heating system. So we have a boiler with a thermal oil circuit, and then we have the other circuit with the organic Rankine cycle. And then, of course, we have also the auxiliary boilers in order to ensure the proper backup for the overall system. Okay, we can go ahead. Here I put also some link to video in order to better understand the operation of organic Rankine cycle, for example. But I think that you can see later after this webinar and this video. Let's have a look also of a case of study. For example, we can consider the Italian case study of Tirano, that is an existing biomass district heating systems with 20 megawatt of biomass installed as thermal power, and with 1 megawatt of the electric power installed. We have a very interesting network of 33 kilometers, and we have also 60 megawatt of thermal power installed at the final user. So this is very important because we consider a factor free from the thermal station to the final user. And also the picture is very interesting because we can appreciate the surface that we have to guarantee for the storage and the supply of biomass. So we have a large area in order to store and treat biomass, wooden chips for supplying then this source to the plant. And then we have, of course, the different section of the plants with the combustion section, the flue gas treatment, the pumping station in order to pump hot water to the network, and offices, and so on. It is interesting to observe that on the roof of the offices, we have also some photovoltaics installation to produce also, in addition, renewable electricity. So now we can go ahead again, and just for giving some results again related to the Italian context, we can talk of a quite recent publication edited in collaboration with FIPER. So this publication refers to a wide survey because we consider 82 plants with a lot of megawatt of biomass installed, and we can try to understand some information, some results about the size of these plants and about the performance of these plants. For example, we are dealing with the quite small system. So we have a lot of systems in the range from 5 to 10 megawatt of thermal power. Almost the half of these systems operate in cogeneration, so they are combined heat and power system. But the size of the cogenerator is under 1 megawatt of electricity in general. And the most part of these systems are located in territories without the connection to the natural gas grid, but we have also about 1/3 of plant located in a zone with the natural gas grid. And we can consider also the the average value of the thermal efficiencies that are around the 80%, while the electric efficiency for the cogenerative systems are around the 15 or 18%. So we can conclude also that all these technologies are available on the market, are mature. We have, of course, the very high cost for the realization of the network, but we can also have some benefits in selling both electricity and heat. So we can go ahead again and consider the main results of this last Italian survey. Just to have a look of these results, because for clarifying very well these results, we must go in detail, and now we don't have time to go so into detail. We can consider that in relation to the ex-ante context, so the context without these plants, so before the realization of the plant or these plants, we can have a fossil primary energy saving around the 70% in comparison to the ex-ante situation. And almost the same is for the CO2 saving. So this is a very important results. And we can also take into account that in Italy, we have a very big potential to realize other similar systems. And we can more than double the actual power installation that we have right now in Italy. But we can go ahead with the other slide about the economic benefit. We don't have only benefit in terms of protection of the forest heritage, reduction of CO2 emissions, reduction of fossil fuel consumption. We have also benefits that are at the economic level, because, for example, if we consider each euros that we can invest to realize the plant, we have a monetary impact that can double these investments in the same territory. And we have also interesting employment impact on the territory in terms of annual working unit. For one annual working unit in the plant, we can have more or less 15 annual working unit in the territory related to other activities that are needed, are related to the realization, the maintenance, and the operation of this plant. So we can go ahead again, and also in terms of environmental benefit, for example, if we consider the comparison between biomass district heating and domestic use of biomass, we can have also interesting savings in terms of particulate matter. So the emission factor that we have for biomass district heating system are similar, for example, to the emission factors that we have for example, for oil boilers in terms of emissions of particulate matter. And this is a very important issue in order to give a proper knowledge about this source. Okay, all these results are related to our survey, so are related to the Italian context of operation, are related to the systems that gave us information and so on. So they are not general conclusion, but are related to our survey. And this other slide, that is discussion, potential penetration in Italy in cold zones without natural gas grid, represent the final results related to our evaluation about the potentiality of biomass in our country. So at least we can double the existing systems. We can add to the existing system again 1 gigawatt of thermal power. So there is an untapped potential in Italy, and I think not only in Italy, but also in other European countries. So even in this case, we have to investigate better and support better the use of these sources. So we can go ahead with the other slide that is about the discussion. Here there are only some picture to open the discussion, because this technology, unfortunately, is affected by some non-technical barriers. For example, we can have the expansion of the natural gas grid that is in competition to the expansion of the biomass district heating. I think that in the last year, the energy market is changed, so this barrier can't be so strong at this moment, but there is again this limit. And then we have the necessity of supporting mechanism from the regulatory point of view, from the economic point of view, in order to give some incentives for the realization of the network. Then another barrier is related to the unexploitable biomass because of some logistic constraints. For example, if we have biomass that is far away on high mountains, so we can't go and take these sources with a proper cost. And then we have another important barrier that is related to the NIMBY or NIM2 syndromes. So not in my backyard and not in my term of operation, for example, but with a proper information, such the information in the framework of the BECoop project, I think that also this barrier can be overcome. So we can go to the final slide. So thanks. I'm here for question and answer, and I'm very sorry for the problem with for sharing the slide, but I think that you followed me by thank you to Marine for this support.
Thanks a lot, Paola. I think it worked well. You were a good leader to push the slides. I cannot see if people are asking to speak, but if you have any questions for Paola or Vanessa, please go ahead. Normally your microphones are working.
Sorry, I would like to ask you the financial sources for your projects. How do you obtain those?
Which one? For the pilot in Valtellina?
Yes.
Maybe it could be interesting if you present yourself. That way we can imagine better our community. Okay, I will try to. So I'm from Poland, and we are trying to set up a new community. So in the Gdańsk region, in Pomeranian. So we are trying. So more or less, we have a kind of the concept how to develop, and one of the key element is to find out, okay, the path which you or the scenario which is the most suitable for energy community in Poland. This is one thing, and the other one is the financial side. So how we can find the funds for such a project. So I wanted to ask you this. Okay. So Paola, do we want to start with the technical and continues to financial, or we do the contrary, as you want? I start with the financial,
Okay, as you
issues.
prefer.
Concerning the financial, we are working on definition of the feasibility study, and in Italy we know that 1 kilometer of district heating in mountain area correspond more or less a 1 million euro. So you have to consider, in our case, in mountain area, so you have to consider as well the density of the habitant to share the cost. But in average, 1 million for 1 kilometer of network. Considering the cost of the central, so production of thermal and cogeneration ORC, so the module of Turboden, we estimated around 3-4 million of euros. So the first one model, it means around 5 or 6 million of euro. We start to ask to look for the call of the regional level in Regione Lombardia, because in the next months the Regione Lombardia got to publicize a new call concerning the first research. And then we would like as well involve the municipality research, and as well the involvement of citizen into the new enterprise and the new deco that we want to constitute to start up.
Okay, thank you. Thank you.
Okay, I don't know if I understood very well your question, also because it is a very complex question. For the definition of a pre-feasibility study of the system, you should consider the potential final users. So you have to estimate also the thermal demand that you are going to expect for the connection to the district heating network. So you have to know, for example, the thermal characteristics of the built environment, and you have to know you have to provide some statistics about the consumption of the consumption of heat for heating homes, buildings, and so on. So you have to take into account the biomass availability and the costs in your market of for supplying biomass to the plant. So the possible agreements in order to have biomass with the proper low heating value, with the proper humidity content, and so on, and the related prices. And then you have to estimate, maybe via a survey, via questionnaires, or also referring to local statistics. I don't know if you have some data sets to be considered in order to define some territorial cluster that can be supplied by these systems, and try to define the most the most proper size in terms of thermal power. So you, for example, I also have to know the heating degree days in your area in order to give you some information from the technical point of view. So I don't know if it can be possible, but also in the framework of the BECoop project, we can try to stay in contact and to support as we can about this technical issue. I don't know if this is a proper
Perfect
answer. Thank you.
Yes, so let me that I will write you. I will take this topic offline. That I will share with you my question, my concept, and where we are with our community. Because in principle, we would like to end up our effort to biomass production, and the heating production in Poland, especially, is we are in favorable situation because in most of the city there are central heating systems. So there is a huge power plant producing heat. So there is a huge demand of biomass, and the production with the using of biomass. So we would like to end up with the biomass production and not going to the heating, because it is already somehow this problem is resolved, only the biomass. So please let me, may I ask you on which email I can contact you? So
you can send to contact@BECoop. It will be simple. You can find the email on the website, and then I will forward it to Paola.
Exactly.
Fantastic.
I will put in the chat. Let me add it in the chat.
Mille grazie.
Niente. I just would like ask. I would like add an element that for us in district community and district municipality was a really great time, because our energy price last year went really high concerning in comparison with oil and gas. So the people were really interested to switch from the fossil, as well from the old little domestic boiler to the district heating. I don't know, maybe in Poland the situation concerning the actual energy price is quite the same as Italy, I suppose.
Yes, we have the same problem, the same issues, and we are trying to resolve this, especially that the biomass production is not so popular so far as in Western countries. So there is a huge potential for biomass gathering and biomass production.
Thanks both of you for joining us today, and for all the participants for having joined as well.
Thank you so much.
Thank you a lot, Vanessa. Thank you a lot, Paola. It was excellent presentation.
Bye-bye.
Have all